In this 13th part, we'll learning about advanced component concepts that will elevate your Svelte 5 development skills. We'll explore the component lifecycle, which helps us understand when and how our components are created and destroyed. We'll also cover props validation to ensure our components receive the correct data types, default props to provide fallback values, component events for communication between parent and child components, and component bindings for two-way data flow. So, let's start with component lifecycle. The component lifecycle in Svelte 5 represents the different phases a component goes through from creation to destruction. Understanding these phases is crucial for managing side effects, performing cleanup operations, and optimizing performance. Svelte 5 provides several lifecycle functions and runes that allow us to hook into these phases and execute code at the right moments. The main lifecycle tools include onMount, which runs after the component is first rendered to the DOM, effect.pre, which runs before the component updates due to state changes, effect, which runs after the component updates, and onDestroy, which runs when the component is being removed from the DOM. These lifecycle tools are essential for tasks like fetching data, setting up subscriptions, cleaning up resources, and managing third-party libraries. Let's understand it with code example. First, create a component in Components folder. Create script section inside it. Import onMount and onDestroy from Svelte. Then create reactive count variable and set its initial value to 0. Create reactive mounted variable and set it false. Create non-reactive previous count variable and set its initial value to 0. Now, create onMount function. This method runs when this component renders in the DOM. Inside it, print a message using console log method. Then set mounted to true. This method can also return a cleanup method like this. This method will return when this component gets unmounted from DOM. Next, we have onDestroy method. This method runs when component is being removed from the DOM. Inside it, we'll simply print the message to see the change. There are two other methods to track the changes while component is mounted in the DOM. First is effect.pre function. It runs before the component updates due to state changes. Inside it, we'll print the previous count value, and then assign new count value to previous count variable. Next function is effect. It runs after the component updates due to some state changes. Inside it, we simply print the count value. Now, create a function named increment. Inside it, increment the count value. Now in template section, create the block. Inside it, create a heading. Then print value of count variable. Then create a button and call increment method on click. Pass some styling and title to it. Now go to main page. Here, import this component. Create a Boolean type show component variable and set it true. Then in template, create button. Pass a method to onClick property and toggle the value of show component variable inside it. Then pass some styling to it. Then pass this ternary operator in title to set it according to show component variable. Then create an if block and check if show component is true. Inside it, render our component. Now run the app. First open the console to see the result. Now refresh the app. Here we can see that effect.pre method run even before onMount method. Then ran mount method. Once component is rendered, effect method ran. Here in template, we have a destroy component button. If we click on it, cleanup function got returned from onMount function. Then ran the onDestroy function. Here we can see the output of these two functions. Now create this component again by clicking on this button. Now we can see the same output which we got the first time. Now click on increment button. There's something wrong because effect.pre function is showing the current value instead of previous value. Let's fix this. Now, if we click on the increment button, we can see that effect.pre function ran first and printed the previous value. Then effect function ran and printed the updated value. Now, if we destroy the component, cleanup function got returned and then onDestroy method ran. These are the life cycles of a component, and this is how we handle different stages of it. Now, let's talk about props validation. Props validation in Svelte 5 with TypeScript ensures that components receive the correct types of data from their parent components. This helps catch errors early in development and makes components more reliable and easier to debug. TypeScript provides compile-time type checking, which means you'll get errors in your IDE before running the code if props don't match their expected types. However, if you need more enhanced or custom validation, Svelte 5 also supports runtime validation through custom validation functions, allowing you to create more sophisticated validation logic beyond simple type checking. Proper props validation leads to better developer experience, fewer runtime errors, and more maintainable code. Let's understand it with a code example. First, create a card component. Create script section. Inside it, create an interface named props. Inside it, create properties that you want to receive as props. Then create variables same as props properties and set its type as props interface, and initialize it with props rune. Then create a function named validate props. Inside it, use if statement to check if rating is less than 1 or greater than 5. Inside it, throw new error. Then use another if statement to check if title is less than 3. Inside it, also throw new error. Next, call this function in scripts block. Now in template, create a block and pass styling to it, and also set background color according to the isActive variable. Then use h3 tag to display title. Then use paragraph to display description. Then create div block and give some top margin to it. Inside it, use span tag and set text color to yellow. Inside it, display heart emoji and repeat it according to rating variable. Then create another span tag and set text color to gray. Inside it, display white heart emoji and repeat it 5- rating times. Then create paragraph tag and display either active or inactive status according to isActive variable. Then go to main page. Here, import this card component. Then display card component twice, and also provide props. Now run this app. Here we can see the cards. Now go back to main page and provide rating of 6. Let's check the result now. Cards are not displaying. To check, open console. Here, we can see the error that rating must be between 1 to 5. It is not ideal to throw errors like this, but it's enough to show you props validation. Now, let's talk about default props. Default props in Svelte 5 provide fallback values for component properties when they are not provided by the parent component. This feature makes components more flexible and reduces the need for complex conditional logic within the component. Default props are particularly useful for optional styling properties, configuration options, and behavioral flags. In Svelte 5, default props are declared directly in the destructuring assignment of the props rune, establishing clear expectations for component behavior while maintaining full type safety through TypeScript. Default props help create more user-friendly components that work out of the box while still allowing customization when needed. Now, let's understand it with a code example. Here, create a card component. Create script section, and then a props interface. Inside it, create a nullable type property using question mark, and assign the allowed string values it can take. It is the string literal union type property and allows only these values which we assign to it. Then create a message property of string type. Then create nullable dismissible property of Boolean type. Then create type variable and assign default info string to it as info is allowed string. Here, this string will act as default value. If user does not pass value to it, then this default value will be used in that case. then message and dismissible variables and set default false value to dismissible. Then set the type of these to props interface and initialize it with props rune. Then create a visible reactive Boolean variable using state rune and set it false. Then create colors object, and inside it, create 3 properties named info, success, and error, and pass these Tailwind classes to these properties. Then template section, use if block and check for visible variable in it. Inside it, create a block and use these classes to give some padding, margin, border and rounded corners, and pass colors object and type property. This will give it color according to the type. Then display message property using paragraph tag. Then create another if block and check dismissible property. Inside it, create a button. Then pass this function to onClick property and set visible property to false in it. Then pass these classes to give top margin and hover color to this button. Now go to main page. Here, import card component. Then render card and pass only message prop to it as it is required. Then render card twice and pass all 3 props to these. Now run the app. Here we can see the 3 cards. First card uses the default info value and use the color according to it, and it also does not have a dismiss button as by default dismissible property has false value. Next 2 cards have different colors and also have dismiss buttons as we deliberately passed all props to these. So they have different colors and buttons. Now if we click on dismiss button, that card is removed. This is how we create and use default props. Now, let's talk about component events. Component events in Svelte 5 enable child components to communicate with their parent components by dispatching custom events. This communication pattern is essential for building interactive applications where user actions in child components need to trigger responses in parent components. Component events follow a unidirectional data flow pattern where props flow down from parent to child, and events flow up from child to parent. This approach maintains clean separation of concerns and makes components more reusable and testable. Let's understand it with a code example. First, create the message component. Inside it, create script section. Then create a props interface. Inside it, create an onClick property, which is a function that takes string type parameter named message and return void. Then create an onClick property of type props interface, and use props rune destructure the incoming props. Here, we are taking a void function with a parameter as props. After that, create a function and name it whatever you want. Inside it, call onClick function and pass string message as parameter to it. It might be confusing right now, but after implementing parent component things will get clear. Next, come to template section and create a button here. Call send message function on button click, and then pass some styling to the button. Now come to the main page. Here, import this message component. Then create a message variable of string type and initialize it with string value. Then create a function named handleClick and pass string type child message parameter to it. Inside it, assign this parameter to message variable. This function serves as the bridge between the child component's event and the parent component state. In template section, render the message component and pass this handleClick function to the onClick property of the component, and then display the message in paragraph. Now, let's understand what we did here. In parent component, we created a message variable with an initial value. Then we created a function named handleClick which takes a string type parameter and assigns this parameter to message variable. Then we pass this function to child component as props. Inside child component, we created an interface which declares a onClick property of function type. This function takes string type message parameter and returns void. Then we used props rune to destructure the incoming props. After that, we created send message function, and inside it, we call the onClick function and pass string value to it as it requires string type parameter. Then we created a button and called this send message method on button click. Now, when user clicks the button, this send message function is called. Then it calls the onClick function and passes the string value to this message. Then this value is passed to the handle click function of the parent component because we pass it as parameter to the child component. Then this handle click function assigns the received value to message variable. As message variable is updated, updated value of message variable will be displayed on the screen. Now run this app to see the result. Here, we can see the button and the initial value of the message variable. Now, as we click on the button, value updates and shows the message which we sent from child component. This is how we handle child to parent events. Now, let's talk about component bindings. Component bindings in Svelte 5 enable two-way data flow between parent and child components, allowing the child component to directly modify values in the parent component. This is particularly useful for form inputs, modal dialogues, and any component that needs to maintain synchronized state with its parent. Component bindings establish bidirectional data flow between parent and child components using the bind directive. This powerful feature allows parent components to automatically synchronize with state changes inside child components without event boilerplate. The child component marks specific props as bindable using the bindable rune, exposing its internal state for direct binding. This pattern is invaluable for form controls, complex UI components, or any situation requiring tight coupling between component states. Bindings maintain reactivity through Svelte's automatic dependency tracking while providing the same type safety as regular props. Let's understand a code example. First, create a slider component. Create script section. Then create props interface, and then create value property of number type. Then destructure the props using props rune. Important thing to do, make this value property bindable using bindable directive and set initial value to 0. The bindable directive tells Svelte that this prop can be bound to from the parent component and provides a default value of 0. Then in template section, create input of range type. Set minimum value to 0 and maximum value to 100. Also bind it with value property and pass this class to set its width. This way, value of this property and the range slider will bind with one another. Then create a block and pass these classes to center the content. Inside it, create 3 span tags. In first, display 0 in second current value, and also pass these classes to make text bigger. And in third tag, display 100. These tags will show the range of the slider. Now go to main page. Here, import slider component. Then create reactive slider value variable of number type using state rune and set initial value to 30. Then create reactive confirmed value variable of number type and set initial value to 0. Then render slider component and use bind directive with the value property of the component and then pass slider value variable to it. This bind directive creates a two-way binding between the parent's slider value state and the child component's value prop. When the slider moves, slider value automatically will update, and if we changed slider value from the parent, the slider position would update too. Then create a button and pass these classes to it and set title of it. Then pass an arrow function to its onClick property. Inside it, pass slider value to confirmed value variable. Then create a paragraph tag and display the confirmed value inside it. Now, let's see what happens here. Here in child component, we declared this value property to be bindable using the bindable directive. Then we bound this value property with this range slider. And in parent component, we declared a reactive slider value variable and gave it initial value of 30. Then we rendered the slider component and passed this slider value variable to value prop. The important thing is this bind directive which allows the two-way binding of the prop and the slider value variable. It's that simple. Now run the app to see the result. Here, we can see the slider with initial value of 30 because we set the initial value of slider value variable to 30 in parent component and bound this variable with the value prop while rendering this component. Also, value of slider and the value of value prop are bound together, so this way default value of the slider becomes 30. Now, if we change the slider, current value also changes accordingly. And when we confirm it, confirmed value also changes. And this is how we bind component together. With this section is complete.